This is section 11.5, and today we're talking about simplifying radical expressions involving division. We're going to learn something new called rationalizing the denominator, and we will be dividing radical expressions. If I have any number, a numerator and a denominator under the radical, I can just divide them I can split them or I can divide them, okay? If I split them, be something like this. What's the square root of 9? And the square root of 25 is 5, so it's 3 over 5. One more example. Square root of 16, 4 over 7. Good. Okay. The same goes that if I have two perfect squares on top of each other, a square root of a number and the square root of another number, not a perfect square, I can divide under the radical. Okay? So something like this would be like this. I could do the square root of 12 over 3 and just divide it, and we get the square root of what? 4, which is 2. Right. The next one, what would it be? What does it simplify to? The square root of what? The square root of 9, which is 3. I would likely skip this step right here and just go right to. Does that make sense? Okay, because I like to move fast through these, and you got a lot of little problems. You don't need to add that extra step. All right, so let's try it. Before we try, so there's 3 rules for simplifying radical expressions. Rule number 1, leave no perfect square factor in a radical. For instance, when you're doing the square root of 50, there's a perfect square in there. So it's 25 is hiding in 50. You have to remove all perfect squares out of the radical. So that would be 5 rad 2. Write that down. You should be writing these rules down. Okay, so rule number 2. Leave no fractions or decimals in a radical. Leave no fractions or decimals in a radical. Okay, so for instance, if I have 3/4, I have to make that become, I can't leave a fraction or a decimal under the radical. Now, I can take the square root of 4, and that's 2, so there's no fraction in the radical. There's only a 3 in the radical. Does that make sense? Okay, number 3, leave no radicals in the denominator. Leave no radicals in the denominator. So if you have a radical in the denominator, Harrison, you got to be writing as we're going. What you're going to do, it's called rationalizing the denominator. So you split it up, and then I'm going to multiply by whatever's in the denominator, a fancy 1. So I'm going to multiply by a rad 3 over a rad 3. And what that's going to give me in the numerator is a 2 rad 3. And in the denominator, rad 3 times rad 3 makes what? Rad 9. And what's the square root of rad 9? 3. So basically, when you have 2 perfect squares, when you multiply them together, I can write the rad 9, but what you get is what's underneath the radical.
How can we put rad 3 next to both of them?
I'm multiplying it by a fancy 1. Okay? Let me put their notes. Maybe it'll look clearer. See? Okay? Pause the recording if you need to finish the notes.